Okay, guys, let's work on this one, number 9 of 17. So this is really easy. Y coordinate of the quadratic vertex. Okay, the vertex right here is right here. That's a vertex. The coordinate is 0, 4. 4 is my answer. Which one of these increases at a constant rate? Okay, so you can graph them all. Constant rate, guys, means a straight line. That's a decrease. That's not a line. Increase, I like it. That one's a quadratic. Does a parabola bit. This one here, I'm stumped on this one. I just don't even get this one. I think there's got to be more information given to us. So I'm going to just skip that one. Let's look at this one real quick. The table of values for a quadratic equation is given on the left. There are two solutions. There is a solution between -2, -3 and -2, then it was another solution. So solution is a key thing right here. Solution means your root, your 0, and most importantly, your x-intercept. Your x-intercept, guys, if you forget or don't forget, is when y is equal to 0. So look, y is equal, okay, so a solution is between these right here, between right here and here, there is a 0. Do you agree? Another thing, when does this happen again? Well, from a positive to a negative, there's crossing the 0 between 3 and 4. You'd have another 0 slash the solution, a root, all that good stuff they're looking for. Let's look at this real quick. Which graph is increasing with a -0? Okay. Again, this is a 0, guys. Very important. You can remember these things. That's going to be your root, your solution, your most important x-intercept. Okay, your x-intercept, guys. That's going to be an x-intercept. These two have x-intercepts, right? Okay, now, so I'm going to say this is wrong, and this is wrong. This one is in the running because I have the x-intercept and the negative. But which one's increasing? Which one's going up? You see how this one's going up? So g of x. This one's going down. Out. G of x. Okay, increasing. Talking about your slope. Remember slope. Positive. Negative. Undefined. 0. 0 is your x-intercept. What's the solution to this? Now, I don't know what to tell you on this one. This is easy, hard, medium. I don't know what to tell you, but if you look at this real quick, this right here, if you understand, this is like your y, and this is like your x. This one's just saying, in all this stuff here, if you plug it in, which one gives you a true statement? Okay, which one says true? What do you mean true? Well, if I put a p here to be 6, and I get a 4 over here, would they be equal to each other? Would that give me 4 plus 10 over 14, over 4 inside? Sorry. Are these things equal? You can never see here. That's 14 divided by 4. Now you go to 6. Out. So it wants to know which one is true for it. You decide how you want to work this one out. And you saw I could do that real quick, so I'm going to do that for the rest of them. -2 is your p. Is equal to 2 plus 10 divided by 4. There's no way I can add up positives. Divide by another positive, we'll wind up with a negative. Here I'm going to go with 5 is equal to 10 plus 10 divided by 4. Ooh, check, that's my answer. 20 divided by 4, 5. Prove that this one's not. So we're going to go with 3 is equal to 0 plus 10 all over 4. So now we have 3 is equal to not even. So let's look at this one. What is the area of the rectangle in terms of x? What's the area in terms of x? Okay, area, don't forget, that goes back to 3rd grade. It's equal to length times width when it comes to a rectangle. So basically we're going to have x minus 3, which is, I guess, your length. This will be your width. And that's going to be times 2x plus 4. So I'm going to have to 4 this one out. Becomes 2x squared. Start looking for that. Out. This times that gives me plus 4x. Now multiply this times this. Negative 6x. This times that. Negative 12. 2x squared. This right here gives me a negative 2x. Check. There's my answer. Given the linear, oh, this one's so easy, so cheesy. You see that one right there? Saying when x is down here, x to be 10, what is my y value? I don't want to think. You can actually think here and figure out right here. Okay, increase of this one is a lot, like 440. So 220 for each one, and 220 plus another times 5. You know what? That's already too much thinking. So I'm going to use a calculator. Since it's linear, I want to use these numbers. Okay. Move this over. I'm going to try to do it. I'm going to do this in spreadsheets. I'm not going to think. I'm going to type in 0, 55, 2, 495. Go in here, go to menu. 4, 1, 3 is linear regression. So I'm going to go to 3. Here comes B. Control that. Enter. So we're going to come here. Oh, I told you it was 220 for each one. I'm going to go in here and add a page. I'm going to add a graph. Press up. Enter. I don't care about that thing. I really don't. I'm going to go to Control T. Add a table. And I want to scroll down to X is 10. You see X is 10? So the Y value is now at 2,255. And there it is, A. Try that one again, guys, on your own. Here we go. How's the graph of fx compared to the graph of g of x? Okay, so imagine this one. Negative slope right here. That's going to be going down. Negative, positive slope, undefined slope, 0 slope. Here it will be positive slope, negative slope, undefined slope, 0 slope. So this one's going up, this one's coming down. We got the same x-intercept. Ooh, they do have the same. Oh, that's y-intercept. Okay, bad. The graph f of x is steeper than g of x. No, but yes. No, they're not. Same steepness. How about that? Because you're coming down a mountain that has a slope of 3, and this one has a slope of 3, but in the negative direction, you're still coming the same speedish. The graph g of x is reflected across the y-axis. The graph of g of x is across. Let me see this one. I understand what that says. This one here is 5, right? And it's going down 3 of x. This one here is the same thing, but going through there like that. This right. And this is the y-axis. So if I bring this over here and this one, yeah, I like that one. These don't have the same slope. Oh, this one's pretty cool. I like this notation. Think about that real quick. I'll stop for like 10 seconds to let you think what this thinks or is saying. It's pretty cool, actually. So when you plug this in here, you plug in 2 for all this stuff, you're going to get a number. Say it's, if you don't mind, 7. When I plug this one in here for the x, say I get, I don't know, 5. The thing it says, get this minus whatever you get from here. And that's going to be 2. So that's basically what it's saying to do. So let's actually try that. Let's try that, okay? So f of 2. If you don't mind, I'm going to just do it right here on top of this stuff. F of 2 right here. I want to have a negative 1 x squared. This is f of a 2. Minus 2, right? Yeah. And then that means this becomes a 2 right here. So f of 2 is now a negative. This becomes 4. This is a negative 4 minus 2. F of 2 is equal to a negative 6. Let's say that's true. This becomes squared, right? 4. 4 times a negative 1, negative 4. Negative 4 minus 2, negative 6. Yeah, that's good. Here, we're going to go minus, right? F of a negative 3, which is going to be a negative 1 times x squared minus 2. Negative 1 times a negative 3 squared minus 2. It becomes 9, right? 9 times a negative 1, negative 9 minus 2 becomes a negative 11. So negative 11. Okay, so basically you have a negative 6 from a f2 minus this is this minus, okay, this minus right here. This minus straight down, which is down. Over here, a negative, negative 3 gives a negative 11. So it becomes a negative 6 plus 11, which gives me 5.